Hello and welcome back to the Design Hub. I'm Molly and today I'm joined with our lovely guest, Kay Bond. Kay, thank you for being here.
You're very welcome.
So to kick things off, the first question I ask everybody is what actually drew you into this industry? What drew you into the side of academia?
So I think it was the academic side more than working in industry. It was partly the realization that I was that engineering and design education really suited my natural instincts and background as a sports coach. I coached swimming and hockey and that kind of thing, and I kind of always believed that people learn best by doing and reflecting and being guided rather than being talked at. I was fortunate to have worked in engineering design and manufacturing, so I designed machinery, manufacturing machinery, and so with an emphasis on more problem solving, iteration, teamwork, the subject really lent itself far more to a coaching model than a traditional chalk and talk. You know what I mean?
Yeah.
And then so I got drawn into engineering and engineering design. My dad raced sidecars.
All right.
So he was a sidecar rider, and he had a motorbike sidecar in the garage. So and I used to get dragged in to hold this, and so pictures of me as a toddler with spanners, a white frilly dress and a dirty spanner. So I got drawn into engineering partly through my dad being a sort of motorbike petrol head. So but then I moved out into the academic level, academic side really. Because on a more practical level, if I'm entirely honest, academia also offered a more sustainable and family-friendly career path than manufacturing industry at the time. It was just easier to do that with the terms and that kind of thing. And also balancing professional ambition with personal life was important to me. So higher education allowed me to continue to work at the cutting edge of engineering and design, whilst also building a life outside of work, with hockey and that kind of thing. And I'm still a hockey coach and manager now. And so over this time, this sort of combination of coaching, creativity, and impact on the students is what kept me motivated, really, in in the academic sphere for over 3 decades. Crumbs, that is a long time.
Was there any subjects that you actually did in school, for example, that like made you feel like, this is kind of the path that I wanted to go down? If you had to incorporate the stuff that you did with your father, did that lend itself to your personal academia?
Yeah, so sadly not. I came from an era where girls did sewing and cookery and the boys did DT. So engineering drawing, tech drawing, all of that was not allowed for me. I've come from that particular era and that particular school as well. So that is sadly not. So it was fully formed and influenced by my background. My dad, to be fair, he worked at a car manufacturer and worked on the shop floor, but was very comfortable pushing me. And so he asked me to do some calculations. So I did maths, physics, biology A levels, and he pushed me to do some calculations on the engine timing, for example, because he had a little black box that you could set the engine timing for firing, the spark plugs, different times, that kind of thing. So he got me to do some calculations on that kind of thing. So he very definitely saw me as being his boy as well as much as his girl, if that makes sense.
Yeah.
He wasn't bothered about gender, so why should I be, kind of thing. Yeah.
And you also said that you've been in academia for 3 decades, which is incredible. And I also know that you've worked with like across new providers, post 92s, and Russell Group universities. So how would you say that those different environments shaped your approach to education?
They're all quite different, and yet they have some similarities. I think it's shown me that no single environment has a monopoly on good education. That is the reality. So, excuse me. Each brings its own strengths and challenges, definitely. But just as influential as the institutional context are the people within it, and that's what's really important. The colleagues, students, and leadership cultures I've worked alongside have shaped my practice as much as league tables and resources. That it It comes down to the vision, I think. I would say, though, that small specialist providers really stand out for the way they enable staff to genuinely know their students as individuals. And that obviously does apply to larger institutions if they've got small programs and that kind of thing. But in those settings, it's easier to build that level of trust and tailor the support for the students, intervene early, and that aligns closely with my sort of coaching-led approach to teaching. What I would say about larger institutions, they offer that scale and breadth and infrastructure. And there's something quite exciting about being able to talk to somebody from arts and humanities about the wider aspects of education and how people learn. But I would say experiencing all three has made me more adaptable, I think. Other people might say otherwise, and reflective. I don't think I was a very reflective practitioner when I first started, even though that was part of my training, but I think that's been reinforced over time. And it's reinforced my belief that effective education is about relationships and inclusivity and designing learning environments that meet students where they are, really.
Well, you said that you don't necessarily like the whole chalk and talk approach to learning. So what kind of experience do you think the students gain from project-based learning? As I know it's quite a big part of your work.
It is. And I would say I wouldn't just stand in the sort of project-based learning space. I would range from inquiry-based learning through to project-based learning. And they're all slightly different, with problem-based learning sort of sitting in the middle. Some people think it's in a different place, but I think project-based learning gives students something that traditional teaching often struggles to give in terms of context and real ownership and developing confidence. By working on those real or realistic problems, sometimes they're more real than others, students should be able to see why theory matters, not just what the theory is, why it actually matters. Those concepts should stop being abstract. Instead, they should become the tools. The concept should be the tools that students should actively choose and apply. And that should lead to deeper understanding and longer lasting learning. It should also develop skills that lectures alone don't easily cultivate around teamwork and communication, resilience, and that ability to kind of deal with uncertainty. However, projects don't always go to plan, and learning how to iterate, reflect and adapt is fundamental to engineering practice. So I think that's the other aspect that it brings. I think importantly, project-based learning teaches us as coaches to teach as coaches rather than lecturers, and to support those students as individuals rather than mass education. It helps students find their strengths and encourages them to aim a bit higher than they initially thought possible, because I think sometimes they just look at the theory and they can't always see that application. It should encourage students to experiment, so that inquiry-based thinking, to experiment, because it should create that safe and structured environment where exploration and iteration are expected rather than penalised. If you got it wrong, that's good, because can you get it right next time? What's your thinking about it? Yeah. So I think you don't want students to aim for a single right answer. You want students to test their ideas and prototype and learn from failure. And that really mirrors real engineering practice, where progress really comes through from that trial, refinement, simulation, and questioning your assumptions as well. And that's something that often chalk and talk doesn't do, because you tell them what the assumptions are when you give them the theory, So you'd want students to build their confidence through the experimentation and build confidence in their own judgment, and that they need to question their assumptions and develop that deeper understanding of underlying principles, as they can directly see the impact of their decisions. I think it also promotes a bit of creativity and innovation. You give them that space. Students can take some informed risks and explore emerging technologies in a safe space or unconventional approaches. And that really, traditional assessment-driven teaching can sometimes discourage that. When the end goal is the exam, where's the experimentation or the creativity and innovation? So that's something. There are pitfalls, but I'm sure we'll get onto that at some stage. But that's why it just allows the world to expand for the student, really.
So would you say that making mistakes is actually possibly a key part in learning engineering and the design?
It is, and but I think making mistakes and reflecting upon them, and questioning yourself and your assumptions, not to the point where you totally always question yourself, but understanding where the limits of your judgment are, your engineering and academic judgment, and working collaboratively, so that if you fail, you need to fail with other people around you so that you can bounce ideas off them. It's interesting because obviously I work for Dyson Institute, and Dyson themselves have about learning to fail and that kind of thing, all over the walls. And it is true that, if you never fail, you never know where the boundaries are.
Yeah.
You never push the boundaries of technology or yourself, really.
Yeah, and I guess students having the environment to basically fail safely
Yeah,
must actually build more confidence because they know that it's okay to
yeah,
fail, I guess.
yeah.
Um,
I
and
think it's about
when,
assessment, isn't it? Sorry,
yeah. Oh,
I
no,
think
no,
it's
go
about
on, go on.
assessment. Yeah, and making sure that the assessment is as much about their processes of getting there as it is around the getting the right number. Yes, we want people to produce good engineering solutions, but equally, what education's about is them learning to produce good engineering solutions, rather than necessarily producing the right number at that point. When they go out into industry, you want them to be more effective, more efficient in producing those good solutions, and that is only through reflective practice and learning to fail and knowing where the failure points are, really.
Mm. And when you're developing or reviewing a curriculum, what would you say like the first question you ask yourself is to make sure that it's genuinely effective?
I think it would be around that, actually, around allowing students to demonstrate their skills and knowledge, without and not just going for the right answer. That exams aren't everything. Exams do something. They do tell you that it's that individual, assuming it's
Yeah.
a closed book, all of that. It's that individual, and they can reproduce the calculations or whatever in a pressured situation. So there is some value to exams, but it is more limited when you want people to be really truly effective engineers. So I think I'd be looking for how people have, say, implemented something like project-based learning, because it's easy to assume that, oh, it's project-based learning, it's going to all going to work, and that's not necessarily key. It Because a key pitfall of technology-focused project-based learning is it can allow students to just plug and play existing tools. It's very easy to get technology, plug and play it, and it all works, and you have no idea why. And students can sort of skate across the surface of engineering and technologies and platforms without really understanding the underpinning principles. So when technologies are highly abstracted or user-friendly, there's a risk that students appear to achieve a working outcome, in terms of a product or a prototype, while bypassing the fundamental mechanics, physics, or material science that make the system really function. So I think this means project-based learning must be carefully designed to really expose and assess the underlying engineering principles. And that would be, what is that genuinely effective? How is that being exposed and assessed? And you want to require students to justify design decisions and engineering decisions, model system behavior, analyze failures, or strip back that black box technology where you can't really see inside. You just know that if you put this in, that comes out, to ensure that there's that depth of understanding. So when done well, project-based learning doesn't really dilute engineering rigor. It provides a really powerful framework for connecting first principles to real-world application, so that students can build systems and explain why they work. But I think if you're looking at a curriculum that doesn't really dig down into the engineering principles, then it hasn't really done its job. So that's that was a long answer to a short question.
And I understand that you're passionate about widening participation. So what would you classes meaningful inclusion in engineering education, like in practice? And do you have any approaches that you found make the biggest difference when you're supporting these like student diverse cohorts? That
It's
was a
really
mouthful, I'm so
challenging
sorry.
question. That's right. I get it. It's really a challenging question, actually, and institutions haven't really found the answers yet, which is why it's always on the agenda. But it goes, meaningful inclusion goes in engineering education, or any form of education for that matter, goes far beyond the recruitment statistics, which is what we tend to focus on. Most institutions have mechanisms in place to attract and admit diverse cohorts. But the real challenge and responsibility for us as educators lies in how well we support those students once they arrive. That's really important. And the thing is, inclusion means really different things to different people, depending on your own experiences and perceptions. It might be about disability or something like that, but it might be about addressing issues such as imposter syndrome, which I can't speak now, which disproportionately affects students from underrepresented or non-traditional backgrounds. And that would be myself, really. You know, my dad was a car worker, and loads of people went to university, and not very, from my sixth form, and not loads went to reasonably good universities at the time. I think inclusion, if we take the wider aspects, is about ensuring that every student feels genuinely that they belong, regardless if they have disabilities or they're, you know, from a widening participation background, you know, whatever that means, that their background and they are valued, and that they can see a future for themselves within engineering, you know, that they can see a pathway through. It's really interesting. I didn't really view myself as widening participation, but I did feel slightly out of place at times at uni. You know, and other people, it's really interesting. Other people have different perceptions of you. I played sport for university, a lot of sport, probably more than I should have done. And people thought, you know, I've got a friend who I'm still in touch with who thought I was very, very well integrated, little understanding that I felt as isolated sometimes as they did. You know, but so I think it's about enabling everyone to get a sense of belonging that goes beyond the learning, teaching, and assessment. You know, you've done your A levels and you get in. You know that, but there's all that other stuff that you don't feel that you quite belong. Have you got quite the right clothes? You know, have you got enough money? You know. So I think how does that impact me in the way I operate? In the classroom, I would say a coaching-led sort of approach with clear expectations, those transparent assessment outcomes or requirements, and that regular formative feedback make a real difference. Building a relationship really with those students so that they feel they belong. And it's not about making engineering easier or lowering standards. It's about enabling students to access what's already available to them, and within their gift. You know, they're quite capable. They come in on their A-level grades. They're good enough already, but it's making them able to access what's there as effectively as possible, and enabling students to understand the rules of the system that they're working within, to feel supported, and that they are encouraged to ask questions without fear. And then they're more likely to thrive and sort of persist and reach their full potential. I hope that's a sensible answer.
That sounds like a very good answer. I do think students being comfortable enough to ask questions, certainly that definitely benefits them. I know sometimes when I was at university, I was a bit nervous to ask questions, but once I got comfortable enough, I felt like I actually could then go on and learn.
Absolutely, and I think that comes out of a bit of a relationship with their peers and and feeling comfortable in that realm, but also having that relationship with the staff as well.
100%, yeah. And on the flip side, slightly out of education, I know you work closely with multiple PEIs, including us at the IED. What would you say is the benefits to academia working with these professional bodies? Like, why would it be considered quite important?
So I work with IED and IMechE and the Engineering Council, So the connection between academia and professional bodies is vital, really. It ensures that engineering education remains relevant and has that rigor and is aligned with the needs of society and the profession. It pushes the boundaries of what we're capable of, really, as HEIs, higher education institutions. It more into the outside world. I think it'd be very easy to be very research focused and stay within your own boundaries, and so it's about education. It's not just about that kind of research alignment. So bodies such as IED and IMechE and the Engineering Council sort of provide that clear framework for professional standards, ethics and competencies, and they help universities translate that academic learning into the sort of professional capability rather than just subject knowledge. So I think working closely with these organisations helps me design curricula and learning experiences that prepare students for real engineering practice, including an understanding of their responsibility and to understand, you know, the importance of sustainability and also lifelong professional development. I think it creates a shared language between universities and industry. I think sometimes we can be in different spaces when we're supporting accreditation and that graduate employability and through professional registration. Ultimately, I think this connection can help students see themselves just as not just as learners, but as emerging professionals. You know, professionals in training is quite often the phrase that's used, who start to understand those expectations and responsibilities that come with becoming an engineer or a designer. And I think that connection is also important for me on a personal, professional level. You know, I want to maintain that contact or context of being a professional engineer as much as being an academic. I'm not a very academic in truth. I'm much more on the engineering design and the practicalities of life. So I think through my involvement with bodies such as IED, IMechE, Engineering Council, etc., I've really built some strong relationships with colleagues from across industry, consultancy, education, and policy. And I think engaging with professionals outside the higher education sector continually challenges my assumptions and broadens my perspective on what engineering practice actually looks like in the real world today. And that goes back into that sector. And I think it's the same for others. I think those interactions develop my thinking beyond the fines of academia, you know, helping me stay a bit more current with emerging technologies, industry priorities and professional expectations. And that's kind of Dyson Institute sort of bridges that really for me. And I think in turn, I would hope this informs my teaching, my curriculum design, which I do quite a lot of, and sort of general research in terms of pedagogy and that kind of thing. And it ensures that what I do in higher education is grounded in contemporary practice and is a bit more responsive to the widening or wider engineering ecosystem, not just the higher education sector. So I'm hoping that for me, that's what comes out of it. That's what I think comes out of it. I hope that's what other people, you know, do get out of those connections. But I think it's really important because that we are training students or educating, should I say, rather than training. We're educating students to become professional engineers, and that's where we want them to be ultimately.
And for any students that are perhaps nervous or unsure about professional registration or chartership and stuff like that, what would you say to encourage them?
What have you got to lose? that is the honest answer. What have you got to lose? Particularly as a student, you know, you rarely have to pay for it. You know, usually your student membership is free. So get involved, really. Get involved as a student, because then you start to see the value of it. Don't just jump onto it after you've left university. But also, you know, professional recognition or working towards being chartered isn't something that limits your options. It only expands them. It can't be a bad thing. It can only expand your options. You're not locking yourself into a single career path. Obviously, I've had multiple. You know, started in an industry and then ended up in academia. but you tend to build towards a portable, respected marker of your skills. You know, it's well understood, particularly outside the UK, what chartered engineer means, and it's a marker of your skills, experience, and professional standards that can travel with you across role sectors and across the globe. Really, I'm going to South Africa in August as part of the International Engineering Alliance to go and review Engineering Council South Africa's accreditation processes, for example. So, you know, it isn't a limiter by any means. And beyond that, the process itself of becoming chartered is valuable. It encourages you to reflect on what you've learned, how you work. And that's what I was saying earlier, that I wasn't a great reflective practitioner. I'm much better at it now. I wouldn't say I'm brilliant, but I'm much better at it now. And it makes you reflect on the impact that you have as an engineer or designer. And even if you ultimately decide not to complete chartership, engaging in professional standards helps you understand your own development and articulate your value more clearly to employers. And at best, it opens doors, builds confidence. At worst, you've gained insight, structure, and professional self-awareness. What's the downside?
Would you say even being a student member actually helps you gets your foot through the door in some cases? Because some companies will look at you and be like, you are a member of a professional engineering institute. And like, do you think that could actually help students, like just from the get-go?
Yeah. It definitely doesn't hinder. I can't talk of specific examples. However, I was on a chartered, sorry, not a chartered, I was on a sponsored program when I was at university. Now it's going back a few years, admittedly. But you know, these things still do exist, and it limited the university I could go to because I had to go to one that had accreditation. When I say limited, it restricted. They wanted a restricted list. They wanted you to go on an accredited course, and we were on the monitored professional development scheme. So some companies are definitely looking for that, but it also shows a bit of a professional oomph, if you know what I mean. That a little bit of drive, a little bit of proactivity in that area, and it may even show companies that you have connections beyond just your immediate cohort as a student, or beyond your company. So you may be able to show that actually you've got further reach than just your immediate surroundings, shall we say.
Yeah. And you've also previously mentioned that where you currently work at the Dyson Institute, it bridges a bit of a gap. And I understand that the Dyson Institute has a very distinctive educational model. How would you say it kind of sets apart from traditional routes? Yeah.
Yeah, I mean, it started off as a bachelor's engineering apprenticeship. And then we've moved on to a sort of sponsored IMechE now. So we've just got the last two cohorts of the bachelor's engineering apprenticeship, which is great. And then we've moved on to the IMechE. And so the obvious difference for an incoming student is no tuition fee debt. And then that early sustained exposure to real engineering work, which many apprenticeships have. Absolutely, and small class sizes, which not everybody has. And those are important, but they're only part of what truly sets the Dyson Institute apart. I think what's far more distinctive is that co-location of the Institute with Dyson's research, development and design functions. That opportunity, which is really unique in the UK, I think, to see the direct application of theory almost daily. Rather than treating industry as something separate or abstract. You go to uni on your 2 days or 1 day, and then I do my work, and never the twain shall meet. And those barriers between the Dyson Institute and Dyson have been eroded more in recent years, particularly, and the academics are starting to work much more closely with the Dyson engineers. And there's a genuine two-way exchange between education and practice. So we have Dyson engineers coming in and teaching, and then the academics are working with some of the research engineers, etc. So there's that crossover of the boundaries. So it's that co-location. And engineers, Dyson engineers, on the Dyson side, as opposed to the institute side, regularly contribute to the teaching, and they bring current challenges and current projects and constraints and ways of thinking straight into that classroom space. So this creates that learning environment where sort of theory, practice, professional culture are sort of tightly integrated, and that helps students develop not just that technical competence, but a sort of strong sense of what it means to operate as an engineer in a real world innovation driven context, really. So it's just that co-location that really sets it apart. And then we have that advantage of very small classes and that relationship with the staff. Yeah.
And finally, my final question, with your 3 decades worth of experience, what piece of advice would you give to students or even early career professionals who are preparing for the future?
It's a really interesting question, that.
I love this question.
Yeah, I'm a long way from being a student. I think I went to university nearly 40 years ago. But I think the advice I would give, and I think this would be the same then, it's simple but important. You're not owed anything. You have to work for your opportunities. And not everybody wants to hear that. And that said, it's much easier to put in the effort if you're working on something that genuinely interests you. So do something that really interests you. And engineering is such a broad and diverse field that there's almost certainly a niche or a challenge that will spark your curiosity, whether that's materials, robotics, design, energy, healthcare, or something entirely interdisciplinary. And if you focus on what excites you, the hard work becomes a bit more meaningful. You're more likely to develop the skills, the resilience, the creativity that will carry you through a sort of long and fulfilling career, I would hope. If you combine that curiosity with the persistence and the openness to learning and a willingness to take on challenges, I think you'll not just survive in engineering, you'll thrive.
That's brilliant. Kate, thank you so much for coming on and talking to me. You've been amazing, and the insights you've given me are incredible. If you enjoyed this episode, make sure to like, subscribe, give us a listen. We're on Spotify, LinkedIn, YouTube, Instagram, Facebook. We're on all of them. And until next time, goodbye.